Okay, so last little bit here is to deal with problems in which we want to calculate the pH or the pOH for our ice tables. In other words, you're going to be missing some parts of your ice table or some information to complete the equilibrium line in your ice table. So we'll have to look at making a couple of other assumptions. Before we get there, we do have to talk about one other thing here. All right, and that is converting the Kas for our acids into the Kb for the conjugate base on our data table. I've mentioned in a lot of our dealings here as we kind of go through the Alberta Ed curriculum is almost every section, every data table leaves off a certain bit of information, maybe to probe for deeper understanding and just to get you dealing with some conversions. And so for this one, you might notice that when you take a look at your data table, while it does have the acid formula, fantastic, it tells us the conjugate base, wonderful, and then it tells us the Ka for the acid, but it's missing a column. All right, it does not have the Kb numbers for the conjugate bases. So if we need these Kb values from the bases that we see in this list, we will have to convert the Kas that go along with their associated acid. Remember that every acid has a conjugate base. If phosphoric acid gives up its proton, it turns into dihydrogen phosphate ion. I have the Ka for phosphoric acid, but I'm lacking the Kb for the dihydrogen phosphate ion. So I just need to be able to convert these. And it's a quick and simple conversion. It's not anything that's going to throw you guys for a loop. All right, we've seen a similar formula to this before. Your textbook goes into obscene detail as to how we create this formula in the textbook. I wouldn't worry about it too much. I treat it this way. This is just another weapon in the repertoire for you guys to move between pH, pOH, Ka, Kb, hydroxide, and hydronium. Remember, these are all related things. We kind of look at the acid side first, and then we make these extra conversions to look at the equivalent basic character. So, Kw, which we already learned earlier on in this chapter, is 1 times 10 to the negative 14. Well, it can be equated as the product of Ka times Kb. Remember that in any Bronsted-Lowry acid-base system, whatever hydronium you get will be the other proportion to the hydroxide in the equilibrium. The two are intricately related. So we can calculate Kb if we just rearrange the formula and divide Kw by the conjugate acid Ka for whatever base we're looking for. Let me show you with an example in number 1 here. All right, there's a couple more in the textbook on page 747 and 748. Please certainly look at them. But we want to calculate the Kb for the hydrogen carbonate ion. Hydrogen carbonate ion is HCO3 with a 1- charge. So we need to find this. And if we're looking for Kb, we're looking for the bicarbonate ion as a base. So we take a look at our data sheet again here, and we have all of our acids, we have all the conjugate bases, we have all the Kas. We can calculate from this formula the associated Kbs. So we look for bicarbonate, and you will find it on the second page, or on page 9. And we find bicarbonate down here as an acid. There's its Ka. But we're looking for bicarbonate as a base. So there it is, existing there as a base, and I'm lacking its Kb. So what do? I'm going to convert based upon its conjugate acid of carbonic acids, Ka, into an associated Kb. That's kind of how this is working, right? Kas are listed for the acids, Kbs are absent for the bases. So you need to find bicarbonate ion as a base, which we just have. So we'll do that one really quickly. And so if we have Kw just being equal to Ka times Kb, then the Kb value is really just going to be Kw divided by the conjugate acids Ka. In this case, you're looking for the Ka of carbonic acid. All right, when bicarbonate ion is a base, the conjugate acid is carbonic acid, as we see on that table. So then we just plunk in our numbers, 1 times 10 to the negative 14 all over, what was it, 4.5 times 10 to the negative 7. That is the conjugate acid Ka. We'll put those into our calculator here. 1 to the negative 14 divided by 4.5 to the negative 7. And it spits out 2.22 times 10 to the negative 8. We're limited to 2 digits here, and so that will round down. And you can see that we match the answer in your notes as 2.2 times 10 to the negative 8. That is the missing value that we don't have in our data table. All right, we have the acids, we have the bases, we have the Ka for the acids. We're missing the Kb for the bases. So when carbonic acid produces bicarbonate ion as a base, the Ka for carbonic acid is 4.5 to the negative 7, and we have said that the Kb for hydrogen carbonate ion is 2.2 to the negative 8. Okay, so you're just looking for these entities as bases when we kind of go through them. Okay, here's for the next one. We're looking for the Kb of hydrogen sulfite ion. All right, hydrogen sulfite ion should be HSO3 with a 1 minus charge. And you can see with the proton and the negative charge that it could potentially be an acid or a base. And so we look for it. Keep going, keep going, keep going. There's hydrogen sulfite ion as an acid. So it makes sense that we would describe its strength or ionization ability with a Ka value, but the conjugate base is the sulfite ion. So we'd be getting kind of the wrong thing. We're looking for hydrogen sulfite as a base. And so we kind of go back up to the top and we find out that it is related to sulfurous acid. So sulfurous acid has a Ka of 1.4. What would be the Kb for the hydrogen sulfate ion as a base? So again, it's just going to be take that Kw of 1 to the negative 14, divide by now the 1.4 to the negative 2, and you can see that we get the missing value that would go here for Kb's of 7.1428 to the negative 13. You had a 2-digit limit because Kw and Ka use 2 digits, so your best answer here is 7.1 times 10 to the negative 13. Okay, those are 2 quick and dirty examples on just converting between Ka and the absent information of Kb for the conjugate bases on this data table. It's a simple conversion. You guys won't struggle with it too much. Make sure that you're doing the appropriate practice in the textbook to lock in this skill, and then we can start using some of this stuff as we get into our equilibrium and ice tables when we're going to calculate things like pH and pOH. All right, so I have one more example to take you guys through in the last video for chapter 16, and we'll see that next.